Hello everyone, welcome to AI Anytime channel. In this video, we are going to develop a Streamlit application that will help you summarize the YouTube video. So the user can input a YouTube URL and the app will give you the summary of that video. So we are going to use a framework called Haystack. We are not going to rely on LangChain in this video. So we are going to combine a large language model through a Haystack framework. So a large language model combined with Whisper, which is an AI model, which is an state-of-the-art speech-to-text model by OpenAI, which is available through both open source and through an API as well. The beauty of this video is going to be entirely open source. Okay, so we are going to rely on open source stack. We are not going to rely on any closed source models or API. So if you go through Haystack documentation, they have a Whisper transcriber and summarization blogs or resources, but those are all closed source, okay, which are like you have to pay for that. Okay, I want to build this application where I don't have to pay a single money, but I can wait for around 1 or 2 minutes to get my summaries if you are running on CPU. So we are going to use a 32K context size model, which is Llama 2 model, but I will show you that model as well, what I'm talking about. And this is the app you can currently see on my screen. It says YouTube Video Summarizer, built with the Llama 2, Haystack, Streamlit, and Love. Right. So if you come on Haystack, Haystack is by DeepSet an open source LLM framework to build production ready applications, as LangChain is not production ready. So we have to explore other options like Haystack, semantic kernel, Llama index, etc. And Haystack is, when you go to the source code of Haystack, they're really, I'll say, production ready in that case when you compare this with LangChain. And that's why a few of the upcoming videos will be related to Haystack and how you can use their prompt notes, their document store, etc, etc. So in this you can see it has an input option which has enter YouTube URL. Now you can enter the YouTube URL over here. So I'm going to take this video for example, which says chunking methods to use custom data with LLMs by Weaviate. So if you don't know what Weaviate is a vector database. Okay, it's available both through through cloud, and also you can set it up in your local machine through Docker or even like from source code as well. So Weaviate helps you build scalable LLM applications where you need a vector database, and that really works well. So I'm going to take that YouTube video, and once I enter that YouTube video here, I can click submit and I can wait for the summary. Okay, so if you can also expand this expander which says about the app. This app allows you to summarize while watching a YouTube video, something like that. And once I click submit, what it will do, it will connect with YouTube first. So we are not using an API, we are using a PyTube library that helps you download the YouTube videos and manipulate the videos from there through only downloading audio or video streams, whatever. So we'll download the videos from PyTube, we'll give that video to Whisper model. Locally, we are running this locally, we don't have any internet connection. So that Whisper model will take that YouTube video, and through basically your speech to text model, it will give you the transcription, and once you have the transcription, we feed it to Llama 2 through a prompt, engineered prompt, and the prompt that we are going to use is again given by Haystack. I will show you the prompt as well once we do that, and LLM will basically summarize that less than in 200 or 500 tokens, whatever you set it. Okay, so let's click on submit and wait for it. So once I click on submit, you can see the app starts running here on the right hand side top. It says running. So this app takes around 2 to 3 minutes depending on how big your video is. So if you see, this video is around more than 4 minutes, and the Whisper model that we are running locally, it can be a base model, it can be a medium or large model depending on that. So when you download the PyTube, once it downloads the 4 MB more than 4 minute size of a video, the Whisper model will take little time. Once you have the transcription, it's pretty fast. So the entire operations take around 2 to 3 minutes to return the result. So what I will do, I will pause the video here and I will resume once it gets completed. Fantastic. So you can see we got our summarization, and in the left hand side you can see the view of the video. the same video that we saw here on YouTube from V8. And here we have two columns. Column 1, in the left hand side we see YouTube video view, and in the right hand side column, the column 2, we have the detailed result. So if you see, this is the result. In this video, the speaker discusses how to use, and we will split that. We'll just parse this output later on once we are building this app. So in this video, the speaker discusses how to use a large language model, LLM, to retrieve relevant information from a PDF document. The speaker demonstrates how to chunk the text data into smaller chunks, which can help. So we got our output, a very beautiful output. This is the context. You have all this document. So this is your basically the transcripts that has been generated or has been created by Whisper model. This is the transcript, which is content. When you ask the large language model a question, it is important something, and you can see it's the language is English. It has a hash keys, the embedding, etc., etc. This is basically a context, and you can see the results over here as well. And this was the prompt, guys. So summarize this document when you ask this last. So simple one-line prompt, and we are not writing any custom prompt for this. We are going to rely on the prompt which is already available on Haystack. So for the summary prompt, that's what we are going to use. And you can see all of your content over here. Your root node, which is file, file path. We have the file path, the video file path that gets stored here in this folder, and then you have prompt, and we also filter out here. You can see in a status message, Streamlit.success message. In this video, the speaker discusses how to use the LLM to retrieve relevant information from a PDF document. This is your basically summary. The speaker demonstrates how to chunk the text data into smaller chunks, which can help the model to focus on specific parts of the document and provide more accurate answers. So we got our summary, and this is the application now that we are going to build, okay, using Llama 2, Haystack, Streamlit. Okay, so these are, and I think we should also add Whisper here, so I will add that we are also going to use Whisper to build this application. So we are combining Llama 2 with Whisper to build this. Now let's start developing this application from scratch, guys. Okay, so you can see I am currently in my folder called YT Summarization App, the YouTube Summarization App. I'm going to open in terminal, and here is my parcel. And first what I have to do is I have to go inside this VENV. So you can see I've already created a virtual environment and installed all the libraries, just to save some time, right? So what I'm going to do, let me open this in code dot. So once I open this in code dot, let me just minimize this, PyCache and VNV. You can see these are the requirements. So we need Haystack. We don't need Streamlit chat. That video will follow up soon, where we will have chat with YouTube video or something, or chat with a local video and chat with PDF as well. Now you see from Haystack, we need Streamlit, we need torch, we need sentence transformers. We don't need sentence transformer in this, but you can keep it in the environment because we can use the same environment for the upcoming videos as well. Then we need PyTube. We don't need fast CPU here, and we don't need C transformers as well, but you can keep it. We don't need C transformers. I will just remove this. Yeah, and then because we are going to use through Llama CPP, I will show you. So we're gonna create a custom script for Llama CPP invocation layer, because officially I'm not sure if Haystack support Llama 2 at this moment when I'm creating this video. So we have to find some workaround at how we can call a custom invocation layer class through in the prompt model option, the prompt model class of Haystack. What does it mean? I'll explain that when I'm writing the code. Then you need Llama CPP Python. I am building the Whisper from GitHub source. So I'm just doing git plus https, Whisper git and cache property, and you need ffmpeg Python as well. Make sure you have ffmpeg in your path if you are on Windows. Okay. Now what I'm going to do is I'm going to create a file called app.py, or let's call this YT summary, basically YT summary.py, and I'm going to also create a file called model.add.py, which is going to be my custom invocation layer file. Okay, what does it mean? I will show you. YT summary model.add.py. Now these are the requirements that we have. Now in YT summary, let's start writing some code. Before that, I will open this image to show you what are the things that we need. So we need a YouTube video URL, as you saw that's going to act as an input file, in this application. Then we're going to use PyTube library, for video download, manipulation, whatever we want to do. Then Whisper model, Whisper model for transcription. There's a typo, excuse me for that. So Whisper model, we're gonna use, as I said, an open source stack. We're not going to rely on closed source for summarization tasks. Because latency might not be a problem for this task, because the user can wait for around 30, 40, 50 seconds or 1 minute to get transcription or something like that. Then you have prompt, which is going to be a summarization prompt, and then we're going to use an LLM. So you can see I have two LLMs here. One is Llama 27B 32K instruct, which is by Together Computer on Hugging Face, and the other is Llama 27B chat quantized 4-bit K small GGUF. This is by Block. So the both are from the Block. These are all quantized model, and they are in the GGUF model. If you are not familiar what GGUF means, then I will recommend you to go to AI Anytime YouTube. Let me show what I mean. And I have a couple of videos on GG. You can look at this Code Llama video 13B GGUF on CPU, or you can also go inside sorts and you can look at GGUF is the new GGML in the LLM ecosystem. You can also look at this 1 minute sorts to understand what GGUF means and why are we using GGUF, or why we migrated from GGML to GGUF in the Llama CPP. You can also look at this video. This is a very detailed video. You can look at it 20 odd plus minutes. Okay, so this is what we are going to do. If you want to download that file, anyway, I will give you the link in the description, but you can again get that from Hugging Face and all. Okay, like you can see, this is a model that we're gonna use. So I'm going to rely on Llama 27B 32K instruct model. Okay, so this is the original model, but I have downloaded it from the blog. The link will be given in the YouTube video description. You can find it over there. So 32K context size is very important, because sometimes video is big. You are deploying this in production. You have bigger videos like 30 minutes, 20 minutes, and the token, there are a hell lot of tokens are there. Then you need a bigger context size, to handle those kind of use cases, and that's why we are relying on Llama 27B 32K. You can use any other Llama models as well. Okay, now here is the channel. You can go through it. You can also look at my LLM playlist. I have more than, now I don't know how many videos. How can I see that? I have around 50 videos on LLM. You can just go and look at it, and you can also look at deploy AI models. There are 8 videos which shows you how you can take LLM to production. Anyway, let's now start writing code. You can see these are the requirement: LLM Llama 2 model that we are using, 32K context size, and I'm going to also show you that how to load Llama 2 in Haystack, for different use cases, for question answering on PDFs, for summarization, for your customer support. It can be any use case, right? CSV files, etc., etc. Let's start writing some code, guys. Here, the first thing that I'm going to do is I'm going to import Streamlit, because we're going to import a Streamlit application. Going to build a Streamlit application. So import Streamlit as st. This is what we're going to do. Now we need PyTube. So from PyTube import YouTube. So we're going to initialize YouTube, the constructor call there basically. And now we're going to use Haystack, and I will request you to focus on Haystack's or semantic kernel or Llama index apart. You can start migrating from LangChain, or you write your own custom pre-processing functions if you really want to build scalable LLM applications. Now haystack.nodes, and what I'm going to do is I need a couple of things. So let me just do import prompt model, and I can also need prompt node as well. So these are the nodes, and that's where we will use this. Basically is like chain. So you have used the chains in LangChain. That's basically how Haystack has a separate like a different mechanism altogether. They have a different way of implementing all these algorithms, like BM search, semantic search, similarities, etc., etc., summarization and transcriber. They have a hell lot of classes that you can explore on their documentation. What we can also do is we can also from haystack.nodes, and I will go inside the audio module, and I need Whisper transcriber, because they are going to use Whisper. You can see it suggesting me over here. So Haystack provides two implementations within this class Whisper Transcriber. One is through API and the other is the local implementation, and that's what we are going to do in this video. We're going to rely on the local implementation of Whisper Transcriber. Now the next thing is I also need the pipeline to run all this whatever nodes that I am currently working with. So from haystack.pipelines, and I'm going to import pipeline here. So you can see it's suggesting me, so I'm going to import pipeline. And now what I have to do is, let me also import time, by the way, if we can use that in Streamlit to see how much time it's taking to do a summarization of a video. Now what important is to show you that how we can leverage a Llama model within Haystack for different use cases implementation. For that, what I have done, I have gone through some of the resources on Haystack ongoing issues on GitHub repository, and I found a workaround, but I had to make some changes. Let me first copy this and bring it in my system, then I'll explain. It's a gist. It will be available on GitHub. Don't worry about it. So now let me show you here what's happening. You can also save this inside Haystack. Once you install in VENV, you can go and make the changes directly in the Haystack script, the base model or whatever that we have directly. But I prefer it doing this way. This will help you, customize a bit. If you see here what I am doing, I am saying that, okay, I'm going to use a Llama model, through a custom invocation layer. So I have a prompt model invocation layer that is from haystack.nodes. And what it does, guys, I will see. So I'm creating a class called Llama CPP invocation layer. I'm going to use a Llama 2 model. Through this Llama CPP invocation layer, I have all these parameters over here that I'm configuring. You can see the maximum context is 32,000 because I am using a 32K context size model. But if you are not using this model, then you have to be very careful of this. You have to tweak this number. Suppose, for example, if you use Llama 27B, then you probably have to do it 1096 or something like that, 1048 or something like that to put the values over here. Now I have to configure all these parameters over here. Most of it are default, and then I am just doing self, and let me just come down. I am ensuring the token limit don't get exceeded, and then I'm just writing a invoke function that will use the model from top that we have defined through all these inference parameters, and then stream it, output, and then something like that, right? So what I'm doing here is we can use this script to load any Llama model in Haystack. And how we're going to do it, I will show that how we can call this script inside a prompt mode, a model nodes inside Haystack. So this is going to work for I think all the Llama models, but if you want to use Falcon, for example, in Haystack, then you have to make some changes in this file to make it work, okay? Because right now this works through Llama CPP and only works for Llama model. Now what I'm going to do here is, or probably you can try out for, I'm not sure that it only works for Llama model, but it can work for Vicunas or Falcons as well, but I am pretty sure that you have to make a couple of changes in the file to make this work, okay? So this is a workaround. Now let's call this file. So let me just save it first. So I'm going to save this and I'm going to call this file. So from model_add, I'm going to import Llama CPP invocation layer. You can see this is the class that we have in this model add.py file over here. Now this is what we did in this file. Now as we are going to work on a Streamlit app, I would like to set the page configuration of my Streamlit application layout. So what I'm going to do is st.set_page config. So let me just do that, and inside this I'm going to pass my layout, which is equal wide. These are pretty much self-explanatory. I have done this in almost all the Streamlit application. Please go and visit my Streamlit app playlist. Okay, there are a hell lot of Streamlit applications using LLMs. Now st.set page config, layout wide, this is done. You can also do a page title or something, if I'm not wrong. Page title, let's do that. Let's call this as something like YouTube summary or something. YouTube summary, or this is fine, right? Something like that. Okay, now when I use a function, so let's write a function called a download video. This will help us download the video from PyTube, which accepts as an URL. So I'm just going to write URL here that is looking for URL as an input, and then I'm going to have a variable called YT. I'm going to call the constructor YouTube, and inside this I'm going to pass my URL. Simple, pretty much very self-explanatory code or human readable code. That's what Python does, right? YT YouTube URL. And now what I'm going to do is I'm going to have a variable called video that will hold my video, and this I'm going to use streams. So yt.streams, you can see this, it's a property streams, and in this streams I'm going to filter the stream, and I only need some kbps or something to define here. So I'm going to call it on basically 160 kbps, and then just do a, let me see, what was that, last, yes. Okay, and you can see get the last stream in the results returned. You can read the functions over here. So you can see define last, and it says get the last stream, which is a property in the results return type stream. So it gives you that video up from there. Okay, YT streams, and I'm just going to return the video.download. So let's just do that, and you can see the video that we have tested it out has been already downloaded, but doesn't make it's okay, because we are going to, maybe we can use some different videos as well. Okay, video.download, and that will help you to download. That's it. So we are okay with our YouTube thingy here. Now we have to initialize the model. So let's initialize the model now. So let me just write a function called initialize. So I hope I'm spelling it rightly. Initialize model, and inside this we're going to use the path of the model. So let's give it full path. This is going to use the path which is your Llama 27. We will define that later on. Initialize model, and then I'm going to return prompt model. So now inside this prompt model I can use the path first. So let me just do model name or path. This is what it looks for, and then it is your full path, which is your model path. And now you have to define your invocation layer, that which invocation layer you want to use if you are trying to integrate open source large language models in Haystack framework. If you don't want to use open source, it's very easy. If you just do here model name or path, just do GPT-4, GPT-4, and the next is API key, and you give your API key to basically create this prompt model here. Okay, so that's what I'm not going to use, because we are going to use an open source model. So model name or path is your full path. Now invocation, so let's define that invocation layer, and my invocation layer is nothing but the Llama CPP invocation layer, and I think this is not invocation layer, this is invocation layer class, Llama CPP innovation. That's it. And as we are going to run this on a CPU machine, but if you want to use on GPU, make sure you have CUDA and kubeless installed and configured properly. You need kubeless set. Okay, you have to force set it or export whatever operating system you are using. Make sure your kubeless is configured properly, and you have your CUDA's kernel set up properly as well. You have the latest NVIDIA driver, your CUDA is working fine, and you have your kubeless set up. Then you can do use GPU equals to true as well. In this case I'm going to call use GPU is equal to false, and then I'm going to do a max length. And of course you can also, I think I had a request from one of my community member that we should have slider or something to handle that. Maybe you can do that in the Streamlit app, some slider to control the maximum length of the summarization. So here we are going to have maximum length as 512, but you can make those changes as well. Now we have written a function that basically leverages the Llama CPP invocation layer, which is residing inside this model underscore add.py file, where we have configured few of the parameters like the max context depending on what model we are using, and then we have insert token limit, and then we invoke the model through this, and that's what we're gonna use this class Llama CPP invocation layer class inside this video here. Now we are done with this initialize model. Now what I'm going to do is we have to initialize the prompt node. It's all node that we are going to use. So in LangChain you use chain, right? So in Haystack it's node. So let's do that. So define initialize again, and I'm not going to call it model. So now it's going to be prompt node, and here I'm going to use my model as a parameter, input parameter. Okay, initialize prompt mode. So let's use a prompt first. So I'm going to do summary prompt, and Haystack provides some default prompt, and that's what I'm going to use. So it's a deep set summarization that we saw once I started the video, right, when I was showing you the app earlier, you could see a summarization prompt over there. So now this is what the prompt comes from. This comes from deep state / summarization, which you can find it on their GitHub repository as well. So this is the prompt that I'm going to use, and now I'm going to create the prompt node. So let's create the prompt node. So return prompt node. So the first thing that is in your prompt node is either model name or path. So let's do that, model name or path, and my model name or path is going to be model, which is my input parameter. We'll call this in Streamlit application. Now model and the default prompt. You can write your own prompt and you can just pass that prompt, like we used to write in LangChain through, and then we used to leverage it through prompt templates in an LLM chain or a retrieval chain or a conversational retrieval chain. You can do it here as well. You can just define something like my custom prompt, docstring, and then you write your prompt and then you use the variable here. You can also do that, but just to keep it simple, I'm just going to use summary prompt over here, and then I'm going to use GPU equals to false here as well. That's it. Let me just do an alt G. I'm not going to use a maximum length over here. This is fine. Use GPU, and this is what it is, guys, now so far. So now this in a slide, let me just plug in my charger. Okay, I think we can do that later. So initialize prompt node, and what next we have to do is now we have to write the transcription thing and then call the model. So now let's write one more function called transcribe. Define transcribe underscore audio, and inside this what I'm going to do now is I'm going to use a file path. So let's call this file path and the prompt node. The prompt node that we have, the function that we have written on top, we'll use that later, this prompt node. Now in transcribe audio, what I have to do first is in that I'm going to use whisper. So let's call a variable called whisper, and here you can use whisper transcriber. And once you click the create this, call this function, you can read the function description documentation. It says it's available. I don't know if, okay, you can see it's available through API, uses the OpenAI API, because Whisper is also OpenAI thingy, and then you can also use local implementation, and you can understand that. Now here if you just write API key, you can just pass your API key, then it becomes closed source thingy. It will be faster for you, of course. It will be really fast, around 20-30 seconds. It will take time to do it, but if you do local implementation, you can see it says requires installing Whisper, that we have done through requirements.txt, and we also have ffmpeg set in our path, okay, user variable path. Now in Whisper transcriber, I'm not going to give the API key. So if you don't give the API key, it means that it's going to use the local Whisper setting, okay, that you have configured, right? You have installed, and you can also pass your models or whatever you have. Large, it has 5 models if I'm not wrong. Now what I'm going to do is I'm going to call a pipeline variable, and I'm going to use my pipeline thingy over here. So let's call pipeline, and you can see I'm just calling the pipeline over here that we have also imported in the line number 5. Now this is pipeline thing is done. Now inside this, I'm going to keep adding my pipeline, so the nodes in that pipeline. So pipeline add underscore node, and the first thing that I'm going to do is the whisper thingy. So let's do component. It accepts component, and you just have to give your variable name here. So my variable name is whisper. You also need a label. You can give a label. So let's give a label to this. So I'm going to give a label called whisper. Let's do that. And you can also define the type of your data, the structure of your data. So in this case, it's going to be a file. So my inputs is nothing but a list file. Let's do that, and this is what I'm going to do. Now we have added the first node in our pipeline. So you have pipeline, and this is the first node there. Add a node, which is whisper. It looks for the file, and it has a label called whisper. Now the next is, let's add that pipeline.add node, and this component is not going to be whisper, it's going to be prompt node now. So let's do that, and let's give it a name. I'm just going to call it prompt for now. Let's call it anything is fine. And then inputs, and inputs are, now it becomes whisper now, the previous one. So let's use whisper. Okay, this is done. I think I have to close this, excuse me. Okay, now pipeline.add node, and now I'm just going to call the function. So output, not call the function, it's going to run the pipeline. So pipeline.run. I don't know, it's not big capital. Pipeline.run, and I'm just going to give the file path. So let's just define a file path, and my file path is nothing but the file path. Fantastic. And just return this output. So let's just do that, return output. And now we are done with our function, guys. So what we have done so far is these are all Haystack thingy and the whisper thingy. So let me just walk you through quickly. We have imported all the libraries, set the page config. The first function from line 14 to line 17, what it does, it goes to that URL of YouTube, downloads the video and return the video. And then we have initialize model, where we leverage a custom CPP invocation layer. We call that Llama model through that file, and we have a maximum length. You can tweak this value. And then we also have prompt node. So we are also initializing that, combining, like you combine a LLM chain in LangChain. In that LLM chain, you give one prompt template and then you give a LLM. That's what we are doing here in this prompt node. We're giving one model and we have one prompt and couple of other parameters you can define, GPUs, tokens, etc. And here also we are having a pipeline, and in this pipeline we are keep on adding nodes. There you have chains, here we keep on adding node. Okay, and return output. Now what I'm going to do next is I'm going to write my Streamlit thingy quickly. So let's do define main, and here the first thing is let's do a title. So st.title, and I'm going to call this as YouTube Video Summary or something like that. Okay, summarizer, let's call it summarizer. We'll give that later. Okay, st.title, and you can also, we're gonna use markdown, and in this markdown we can define some style. So let's do that style thingy. So style, and here in the style I'm gonna use an h1 class. So let's do h1 class, and in h1 I'm gonna go color. Let's don't use a red color, by the way. I used pink. Okay, or let's use orange. So color orange, and we can also give text align center because we want that title to be in center. So let's call this text align center. I hope I spelled it right. Text align center, and then you have, after that you close the style. Now once you've done this, what you have to do, you have to do unsafe allow HTML equals to true to run this in your Streamlit thingy. Now st.subheader, so let's do that, and in this subheader what I'm going to do is built with Llama 2 whisper Haystack and Streamlit or something like that. Okay, fine. Okay, let's call it Streamlit, and okay, let's let it go a little bigger. What I'm gonna do is I need a love emoji or something like that. Okay, where can I get this emoji? Okay, let's copy this, come back over here and put it here. And now the next thing is I also need a llama emoji. So let's take this llama emoji. Let's copy this llama too. All of these are animals. It's nice to see, right? We give value, prioritize animals like falcons, llamas, alpacas. These are all some species, right? Whisper Haystack, blah blah blah, right? And the next is video file icon or something like that. Okay, movie camera emoji. We're just gonna copy this from here, come over here and paste it here. That's it. Fantastic. And I'm just going to copy this again, markdown thingy, paste. And in this I'm going to call this an h3 class. From orange, let's don't keep it orange. Now call this as maybe probably pink. So we can keep this pink, and h3 color pink, text align center, and then style, unsafe allow. Fantastic. And we are okay with our little bit of decoration of the app. And let's have an expander that will help you explain the app a bit with st.expander, and inside this I'm going to write about the app. And now here you can again use markdown or write or whatever function of Streamlit. So I'm going to call it what should we call it? This app allows you to summarize YouTube video, summarize YouTube video while watching or something like that. Okay, while watching. Okay, and then let's have one more htwrite inside this. Enter YouTube video URL and click on submit button to start. Widget AI anytime. You can also give hyperlink. I'm not doing it. Widget AI anytime to learn more about LLMs, more projects about LLMs, not collab notebooks. Okay, ht.write and this expander, and what next we can do is, okay, enough of decoration guys. Now let's do one thing. YouTube URL, a variable that will hold our input, ht input box or something like that, text input. So you can see Streamlit provides 3 different ways of accepting, which is text area, text input, and it also has some others, but text input and YouTube video URL to text and something. Okay, now this has my YouTube URL, this variable, and now I'm gonna have a submit button. So let's do if ht.button, I'm gonna call submit, and in the same line you can also do a validation check, and there's a value inside this YouTube URL. Then you will execute the below code, and that's what you're gonna do. So let's have a file path here. So file path, and in this file path what you're gonna do is you're gonna download video, okay, and pass this YouTube URL. So we leverage the first function. Now this function has been executed. Now we are running this function over here. That work is done. So that function now can take a chill pill. And now what I'm gonna do is, now I have to run my charger here, but I'm not able to get it on. But anyway, I'll write this code faster now. File path, then the full path, which is your model path. So let's call this model. So Llama to 30B, this is my full path, and now we'll keep on calling the functions that we have defined on top. So on full path you can see we have defined this model path that we have downloaded the model. And now let's call that model. So model variable, and I'm going to use this initialize model. And inside this initialize model, I'm going to pass this full path. So you can see first function and second function, this both can take a chill pill now guys. Okay, we have used these functions now here. And now what I'm going to do next is the other function, the prompt node. So let's call a variable called prompt node, and in this prompt node I'm gonna call initialize prompt node, initialized prompt node, and in this initialize prompt node I'm gonna call this model that we have on line number 55 variable. And now that function has also been called. You can see this has also been called, and we have couple of more. So let's do that. Prompt node is done. Now what I'm gonna do is output, and this output, you know what we have to do. So in output we have to call transcribe audio, and once I do that, it accepts 2 input parameters. You can see file path and prompt node. So we have to do that as well. So let's just do file path, which is we have in line number 53, and then we have prompt node that contains our model thingy as well. So prompt node. So output is done. And now what I'm going to do, I'm going to call couple of columns. So column 1, column 2, st.columns. I'm going to give equal distribution to both the columns. You can do one by one inside a list. You can also do st.columns too. You know, depends what you want to do. And now with column 1, so inside column 1, let's give some header guys. So let's just view the video. So st.video and just YouTube URL, by the way. Okay, excuse me. Okay, I think we can use this. We should have created this column on top itself after the st.button itself, because column 1 we should have the we should immediately get the video, and because it's take load the, but anyway, it's fine. You can make some changes, right? I hope you understood what I'm saying, because now what you are doing is you are executing all the functions, so it takes around 1 to 2 minutes to execute, transcript, and then give it to LLM, and then you get your column 1 thingy over there. So you will say, where is my video? I can't see it. But you can make the changes. You can call this function on, we can define this column 1 just after this line number 52, and you can just immediately call this column 1 URL, because you will have that URL from here, right? So you'll be at least able to give some visuals to the end users, so they can at least watch the video. Okay, now with column 2, what I'm going to do is, let's have a ht.header here, and inside this header I'm going to call this summarization. So let's do that, summarization of the YouTube video, and this is my header, and let's write the output directly. So ht.write output, and I'm going to have a success, and I will pass that output that I've shown you in the beginning of the video. You're only going to have this result first, index 0, and that too after splitting it, the instruction, the prompt that we have. So ht.success, and I know how to do that because I already have done it. That's why I'm just writing it. So output, and that's the results, and we also know that it's first one, results, and then we do split, and once we split, Llama 232, okay, yes, and I think it's inst, yes, instruction, and then that's it, instruction, yeah, and we will get this success. Fantastic, we are done, guys. And now what I'm going to do is main and main. Now I will explain you one last time the code before running it. Very simple, no API keys, no closed source models, all open source. YouTube summary, you have local videos, you have thousands of your knowledge bases in your organization, you have your recordings, you have your Teams meeting, you have a Zooms meeting. You can take this, create minute of meetings, next step, you can write some prompt, summarize it, you do whatever you want to do with this, right? You can extend it further. And what we are doing here, you can see we have imported all the libraries, we have set the page configuration. We have one function that's download video, then we have initialized model that initializes the model through a Llama CPP invocation layer. We have prompt node where we define the prompt, and we use that prompt node, like we use the LLM chain or retrieval chain. In this case, it should be counterpart should be LLM chain because it's a summary task. And then we have transcribe audio where we use the pipeline, keep adding nodes in that pipeline, and then we run those pipeline once all the nodes are inside that pipeline. And then we have a main function of a Streamlit, some decorations, and then we have a variable that takes your YouTube URL. Then we call all the functions, and we are using a model by Together Computer. Credit to them, by the way, credit to everybody who is working to strengthen the open source community. And then we have your columns and just calling the functions, parsing the output. That's it. Now let's do one thing, let's run this guys and see what kind of output that we are getting. So to run this, what we have to do, we have to first, yes, go inside the VNV scripts, and then do /activate couple of cd dot and clear, and then Streamlit run YT summary, which is our file name, .py, Streamlit run YT summary.py, and we expecting that this will open a new tab in the URL, and you can see it does, but probably for the first time when running it will take time, but it's okay. So meanwhile, let me just close this emoji thingy. This is the invocation layer that we have, and this is the Haystack. I'll give the GitHub link as well. That's documentation. Fantastic. This is much better, faster. The time that you see this app takes is mostly due to Whisper, because we are running a Whisper model. that takes a little time to get the transcription out. For question answering, it's pretty fast. I will release that video very soon on question answering using Haystack and Llama 2 the same way that we are doing in this video. But for more question answering through Phase CPU or Waviate or whatever, we can use it as a vector store or a vector database respectively. And let's now use this same YouTube video. You can take any other YouTube video. I was going through that video, so I was just curious. You can take any other video, you can take video from my channel as well, if you want to do that. Okay, let's click on submit. Now once I click on submit, it will take around 1 or 2 minutes. By the way, it cannot take up to 2 minutes as well, because you have 4 minutes of video, YouTube video. The transcription takes all the time, and after that you give it to LLM to summarize it. So I will pause the video and I will resume the video once it gets completed again. Yes, so you can see we got our output, guys. Summarization of YouTube video. Come down, and this is the summary. In this video, the speaker discusses how to use LLM to retrieve relevant information from a PDF document, blah blah blah, and you have the entire context, results, prompt, invocation context over here, and all these details. If you click on this basically it's a JSON kind of a thing. If you click on this, it kind of hides that, and you can just get this summary here in ht.success message. In the left hand side, if you have a preview, and it took around 2 minutes for me in my machine. I don't know how much time it's taking in your machine, but depend. If you have a GPU, it's probably faster, around a minute, something like that. But I feel that is completely fine, right? This is not a chatbot where you looking for immediate responses. So latency, it depends what you want to do with this application. If you want to do batch processing, it will be completely fine for wait for a few minutes to get your output, because you are not paying anything, right? Now if you click here, you can find the result. We have parsed the result through that split that we have used, the split function. Here is your entire transcription, the transcription of that YouTube video. You can also return that document content if you want. You can just return this content from this document. Okay, so documents and content. If you want to print the transcription as well for the end user to understand what was the complete transcription, and the summaries can be found over here. You can see the very beautiful little summary that we have, and you can increase the maximum length tokens as well to get a bigger summary or something, depending on how do you want to do that. So that's all. The code will be given. It's already on my GitHub repository. You can find it over there. I'll give you the link in description for the code base. And yeah, so there are a couple of videos that I'm working on Haystack. One is again chat with PDF for some use cases, and the other is going to be something like chat with your video. This one is summary, but we'll have chat with your video. We can chat with your video. So there's a couple of Haystack video, and probably we can also containerize this. We can create a Docker image of this first, and then we can also containerize this. If we want to basically deploy this somewhere on Azure through container instances or web app service. So let's see that if you want to do that. So yeah, that's all for this video, guys. Please like and subscribe. Like the video and subscribe to the channel if you haven't done yet, and please share the video and channel with your friends and to peer. If you have any thoughts, feedbacks or comments, please let me know in the comment box. You can also reach out to me through my social media channels. That's all for today's video, guys. Thank you so much for watching. See you in the next one.